Hello and welcome back to my channel. Today on the bench I have these two Miron63 testers V3. They are multi-purpose testers. They can test capacitors, ESR, inductance, small capacitance, frequency, and more, and small resistances, and much more, straight in the circuit or out of the board. The owner forgot to discharge some capacitor he tested with them, so they got damaged, and he sent them to me to have a look at them and see if I can fix them. From what I can tell, it is an open source project belonging to someone called Miron63, and the project can be found here in this page along with other projects of his. I'll put the link in the description down below. On the user profile and on this website, there is not much information, but he does seem to have a YouTube channel, and it says he is from Belarus. I'll put the link to his channel in the description down below. Even though the videos may be in Russian, I think there should be some English captions so you guys can watch them. One of the links on that website is the manual for the tester, but the original PDF document is in Russian. Someone here in Romania translated it in English. ESR electrolytic capacitors, capacitance electrolytic capacitors between 100 nanofarads and 60,000 microfarads. Small ESR between 0 and 50 ohms, inductors between 0.1 microhenry and 1 Henry, small capacitance, non-electrolytic, between 1 picofarad and 2 microfarads, frequency up to 50 megahertz. It is powered from a 9-volt battery. Pause the video to read this. I'm not going to read everything here. It is way too long. I will also put in the description down below a link with this manual and the schematic for this tester. This is one version of the schematic. Complete schematic of the tester. This is the input side for measuring electrolytic capacitors, and this is the one that must have got damaged, because the owner told me he tested some large electrolytic capacitors but forgot to discharge them. It also have a inductance and small capacitor input tester in here in this section, and this is where the frequency gets measured. I'm not sure how it's testing the capacitor. It does seem to have some constant current sources, two values, 2 milliamps and 10 milliamps. So it must test the capacitors in some high frequency pulses. Not sure how it measures the ESR, but the read value is very precise, despite the fact that these op-amps are not a precision op-amp. But I'm guessing the software for this PIC microcontroller does most of the hard work. Anyway, this is the side that must have got damaged, and most likely these diodes should be shorted, or at least one of them. Probably this one. No, this one. Maybe this MOSFET also. The op-amps seems to be powered from plus minus 5 volts, right? Yes. So if a large negative voltage got through to the microcontroller's input, then the microcontroller is probably dead, or at least that input. So yeah, that would be bad. I do not have this microcontroller, and I'm not too keen about programming. So let us hope it is okay, and only this part is damaged. So let's open them up and see if we can do anything to fix them. How do I get the board out? Maybe this screw releases this side. Let's see. Yes, it does. This is a 3D printed case. How do I get the board out? Maybe I need to desolder these connections, and also these RCA sockets, and then the board. No, it can go this way. It could only come out this way. Anyway, let's see. Yeah, the solder wick seems to do its trick. Is it free? It seems to be, right? Or is it not? Pretty tight margins on the assembly side. I think I will need to desolder this ring or whatever it is. Also the power supply wires. How about now? Yes. Hopefully the pad wasn't damaged. There is one more left, but it is hidden behind this button. I do not want to damage the button. It will be fun soldering that wire back in its place. The ground connection. Yay! The board is out. I did manage to damage this button a bit, but not that bad, so it wouldn't work. There is not much on this side. All the electronics are on this side. The input for the SR reading is in here. This is that MOSFET, and this must be the diodes. Yes, UF4007. There are markings with the values. That's great. Let's set up the microscope to have a closer look. As I said, I set up the microscope just to have a closer look at it. And this is the electrolytic capacitor input side. This is that MOSFET BUK927755A. I will put out some info on editing. And these are those two diodes. They are not UF4007, just your basic 1000 volts 1 amp diodes, SMD diodes. You don't need fast diodes here. And what do we have here? Ah, yes. These are the current sources. 431. This must be the op amp. Yes. 082C. Yes. From ST. I'm guessing this is some calibrating trimmer. This is a voltage regulator. Not sure what this IC is doing. Come on. I'll put out some info on the screen on editing if I can find any. And this must be the microcontroller. PIC 16F886. Another batch of diodes. More passive SMDs. Not sure what this is. Some transistor. Oh no, it is a Zener diode. BAV99. Or is it just a fast diode? Anyway, let's see. Let's see here. This is what we need to check, these two diodes and the MOSFET. Yeah, so one of them is shorted, and since the MOSFET is in parallel with them, it too must be shorted, right? Yes. Let's take out the diode first and see if the MOSFET did survive. Okay, so let's see which of these two diodes is shorted. This one seems to be okay. How about the other one? Not shorted. Then the MOSFET is shorted, right? Yes. It all looks good on this side, so no damage on the board. I hate black solder mask. Following the traces is awful. I want to see if this gate resistor is still okay. It should read 100 ohms. Yes, it does. This is all that it stands between the gate and the microcontroller. And if the MOSFET's gate got shorted, then it could have sent a high voltage pulse to the microcontroller. And if the microcontroller got damaged, that resistor would also have gotten damaged. Let's see. Do I have a shorted gate? Seems to be. The MOSFET seems to be shorted all the way, but I'm hoping that since it got shorted between the drain and the source, it shorted that capacitor, so no high voltage pulse got through to the microcontroller. This is the original MOSFET, BUK927755A. It is a NMOS, 55 volts, 18 amps, and 65 milliohms on the RDS zone. DPAC case, and quite low on the input capacitance, under 500 picofarads. I'm guessing it needs to be since it is controlled directly from the microcontroller. I do not have this MOSFET. The best I can do for now is this one. Another N-channel MOSFET, same case, 60 volts, 37 amps, 20 milliohms on the RDS zone. but it is significantly higher on the input capacitance, but it should work at least for testing purposes to make sure that the tester does work and it doesn't have anything else damaged. And after that, I can order some more suitable MOSFET for this. So yeah, I will try this one. And if the tester is working, then I will order some better MOSFETs. So these are the replacement MOSFETs, which I'm hoping it will work. The drain pad seems quite small, unfortunately. Let's see, do I have continuity on the drain from here to here? Yes, I do. And the source? Yes. And since these two diodes didn't got damaged, let's put them back on the board. I have soldered this board with the buttons in place just for testing purposes. I want to test this analyzer outside the case just to make sure it does work, and then I can put it back in its case. So let's put a 9 volts battery in, and let's see, does it turn on? Yes, sir. Does it turn off? Yes. I have here several capacitors to test. The read values could differ if the tester was somehow calibrated with that original MOSFET in software, but it should be close enough to confirm that the tester is now working. So this is a Nichicon 470 microfarads and 50 volts, and this is the ground, and this is the plus input. Let's see if I can. It does read 414 microfarads and what, 30 milliohms. So it seems to be working now. Even lower ESR. This is the lowest ESR capacitor. Another capacitor, this one is from Panasonic, 100 microfarads, 50 volts. Yes, 96 microfarads and 20 say 20 milliohms. Very good capacitor indeed. Another Panasonic capacitor, 47 microfarads, 25 volts. This is a bipolar capacitor, so it doesn't matter which way around you test it. Yes, 44 microfarads, and what? About 400 milliohms. A 220 milliohms power resistor, but not in this. This is the low resistance setting. Let's see. I need to spread the pins a bit more maybe. Yes, 180 milliohms. Remember, it may need calibration with this MOSFET, and also it was calibrated with the wire and this testing end, so it is normal to read differently, but the main thing is that the tester now works. So yay, victory, right? Let's see if I have a working inductance and low capacitance tester. This is the one. Does the button work? Yes, it does. First, the capacitor. I have here an 8.2 picofarads COG capacitor. The dielectric, that is, COG. And let's see. No, maybe if I solder the pins, since touching them misleads the tester. 6 picofarads. It may need some calibration, but it does work. And let's see the inductor. This is a 22 microhenry inductor. (22 microhenry). Yes. So the tester, it is working. Let's turn it off and put it back in its case. Actually, no. I won't put it back in the case because I want to order a better MOSFET for here. And then I will put it back. I won't do a video on that, but there isn't much left to show you guys. Then let's see the other one. This seems to be an older version. But it is the same tester. How do you open? Yes. A handmade case made from PCB boards, but they seem to be quite precisely cut and put together. Also a handmade PCB. This one is a 040N03L. a different MOSFET, but the same 100 ohm gate resistor. And where are my diodes? Are they on the other side? They seem to be. Maybe this has through-hole diodes. And the microcontroller, the same, PIC 16F886. Yes, through-hole diodes, look, for input protection purposes. These are the ones. The diodes are out of the board, and let's test them. Are they shorted? Yes, this one it is. How about this one? No, this one is fine. Only one diode, which is normal. So are they 1N? Yes, 1N4007. What about the MOSFET? Is it shorted? No, it doesn't seem to be. Yes, the MOSFET is okay. Then why did the MOSFET on the other tester got damaged? Before the diode shorted? This is the MOSFET in this tester. And look, 30 volts and a much higher current rating. Also a very low RDS on. Pulsed drain current 200 amps. While the pulsed current from the MOSFET on the newer tester is only 73 amps. So this could explain why this MOSFET survived and only the diodes got shorted. Also, this MOSFET seems to have 2.2 nanofarads on the input side. So maybe it is not calibrated for input capacitance. This is the MOSFET I put in that newer tester, and its input capacitance is 1.9 nanofarads, and the output capacitance is quite low, 155 picofarads. And look, the MOSFET I used does have a gate threshold of typically 2.1 volts and maximum 2.7. Remember, it needs to be a logic level MOSFET, since the microcontroller only gives out under 5 volts. And look, this is the transfer characteristics for that MOSFET. At 10 amps and 25 degrees C, I need just under 3.5 volts on the gate, and the microcontroller is powered from 5 volts. So I'm guessing this MOSFET can stay in place. I don't need to replace it. The MOSFET on the newer tester, the graph doesn't even go to 5 volts VGS, and on 4 volts the MOSFET can sink over 40 amps, 45 or thereabouts. So yeah, that MOSFET can stay in its place. The RDS on it is lower. How about the pulse current? Only 60 amps. No, it is not good, right? So maybe I need to get me this MOSFET. 200 amps are way better. Very low ESR. And what about the gate threshold? Yes, typically under 2 volts. So yeah, I will search for better MOSFETs for the other tester. But at least now we know why that MOSFET gave out, why it got shorted. I have here two new diodes, UF4007, the ultra fast version of 1N4007. I have the diodes on place, so let's solder them. It all looks good now. There was a solder bridge here, but now it is okay. I did put a battery in, and let's see, does it turn on? Yes, it seems to be. It turns off. So let's see, what does this one say about this 470 microfarads capacitor from Nichicon. 460, 65. So yeah, maybe that one needed calibration, or it needed the wire. It was calibrated with the wire, but what does matter is that it is working. 107 microfarads. I'm not sure this one it is calibrated. 107 microfarads seems a bit on the high side. 50. No, it seems to need calibration. How about the low resistance reading? This one also seems a bit higher than the other one. I have here a precision 100 milliohms resistor, SMD resistor. Let's see. So yes, it is a bit higher. It does need calibration. But what matters is that it is working. So I can put this one back in its case. Let's try zeroing out these testing tips. First I need to set to constant resistance, to small resistance testing from this button. Then I need to short out the tips and press simultaneously these buttons plus and minus and release them. So now it reads 0. Let's see. Do I have a closer value to the 100 milliohms? Hundred and 4 milliohms, 102. Yes, this should be okay. How about this 220 milliohms power resistor? Let's see. Yes, much better. 219. For zeroing out the tips for capacitance testing, I did get back to the ESR testing, and I need to short the tips and press the minus button. Yes, the value seems to be close. So what about now? 465 microfarads. What about this 100 microfarads capacitor? Still 108. No, can't be right. Let's see what my own tester says about this capacitor. This tester is calibrated. So the same 100 microfarads, 96 microfarads. So yes, this tester needs calibrating. And they say you need to use a calibrating capacitor between 470 nanofarads to 4.7 microfarads. I don't have a precision capacitor in this range, so I need to test it with this tester to make sure I do have a reference value. Then calibrate that tester to read the same. And I have 2.32 microfarads. So to calibrate this tester, they say that from the off state, you need to press and hold the set button, then the minus button, then release them. Then connect the testing capacitor and adjust until I have the same 2.32 microfarads. and save with set. Save EEPROM. Let's turn it off and try it again. 2.32 microfarads, or is it? Yes, it is. So what about now? Still over 100 microfarads. Let's try and calibrate it with this capacitor. Maybe it needs calibrating on this range. So, as I said, 96 microfarads. This is what it should read. So turn it off, press and hold set, then minus, then release. Hundred and 8 microfarads. Let's see. Now it reads 96 microfarads. How about the 47 microfarads capacitor? 44. And what does this tester say about the same capacitor? 44. Yeah. What about 470 microfarads? 450 on my tester. What does this one say now? Yes, about the same. Maybe a microfarad lower. What about the ESR? About 40 milliohms. Same here. 40 milliohms. Just on the edge on the capacitor reading, look, 414, 415. So it can stay like this. Did I mess up the low resistance measuring? Let's see. The same 100 milliohm precision resistor. 101. Yes. So it is okay. I can calibrate this as well. From the off state, I need to press and hold the set button, then the plus button, then release. Now connect the testing resistor. It will be more difficult. I think that's it. So let's see now. Low resistance measurement in DC. Yes. So this one is okay. Is finished. calibrated and tested. This one, the newer one, I will search for a better MOSFET for it, but I'm thinking I could add some SMD fuse holder in series with the minus wire, with this one, just to protect the semiconductors whenever the user forgets to discharge the capacitor. The MOSFET or the diodes will short out the voltage on that capacitor and the fuse will blow, saving both the MOSFET and the diodes. And with some calibration, the presence of that SMD fuse should not influence the precision reading. So yeah, I will search for better MOSFETs and for some SMD fuse holder, because I do not have anything at this point. And when I get them, maybe I'll do a follow-up video, a short follow-up video with the MOSFET replacement and the fuse, and also calibrating and putting it back in its case. So for now, this is it. If you watched my video, thank you very much. If you liked it, please subscribe and hit the bell notification. Also, if you want to support me, you can do so by buying super thanks or by becoming a member of my channel. So until next time, thank you for watching and bye.